In this video, we'll define and execute a complete test using TrueBench, using a clean, repeatable structure. No complexity, no tuning, just the foundation you'll build everything on. Most systems are constantly changing, often without you realizing it. Queries evolve, data changes, platform and components get updated, and over time, results become unpredictable. Without a simple, repeatable way to define and execute tests, it is difficult to know what changed or why. In this demo, we'll define a test using a set of query files. We'll apply parameters to those queries so they can run with realistic inputs. Then we'll execute the test, first in the full screen interface, and then rerun it from the command line. Finally, we'll assess the results that TrueBench automatically captures from every run. We've already downloaded and unzipped the latest TrueBench release. The startup script has been configured with the database credentials, and the required driver is installed automatically. We'll cover that setup in a separate video. Let's start TrueBench. By default, TrueBench starts in the command line interface. To enter the full screen environment for defining tests, use the screen command. This interface allows you to define, execute, and manage tests interactively. Later, we'll return to the command line to rerun the same test. We'll start by defining a simple serial test. The test name allows TrueBench to automatically compare runs of the same test over time, and we can add a description for reporting and documentation. Next, we'll define a queue of work. For this demo, we'll use a single queue containing all queries. You can type queries into the work item, or you can use a file reference. We'll use F2 to browse for the queries. Under the scripts directory, I've saved a set of 22 TPCH queries, modified to include parameter markers for constraints. The queue type is SQL, and we'll use the default execution settings. Before executing the queries, we need to set the database context for the session. In this case, we'll point to a 1 GB TPCH dataset. Next, we define parameters. TrueBench automatically associates parameter files with queries with the same name. This allows the same query to run with different inputs. Parameters are delimited by a vertical bar, and since this is a serial test, the parameter counts are not relevant. Now we define the worker that executes the queue. The alias represents a database connection. For this test, we'll use a single worker, executing queries one at a time. That's all we need for this test definition. We'll use a fixed work execution, running each query once. With one queue and one worker, this is the same as a serial run. Now we'll execute the test. At the top of the screen, you can see the elapsed time and query count. The center shows the execution log, including statements and updates. The startup configuration also defined before and after statements that update a test tracking table in the database. This allows you to correlate the test run with database queries logs, so you can analyze what the system was doing during the execution. The run completes successfully, executing all queries without errors. This gives us a clean baseline for further analysis. We'll exit the execution log and save the test definition using F6. TrueBench uses the same test name as the file name and stores it in the scripts directory. At this point, we could use F2 to load a save test, F8 for a new test, but we'll use F3 to return to the command line interface. The test we just defined has been saved as a script. The script contains the full test definition, including the queue, parameters, and worker configuration. We can now execute the same test directly from the command line. That makes it easy for us to automate and rerun the test consistently using the TrueBench scripting language. As before, the test updates the test tracking table, allowing correlation with database activity. At the end of the run, TrueBench summarizes recent executions and suggests using the assess command. The assess command compares two test runs. At the top, we see the baseline and the new run, both using the same test definition. First, TrueBench verifies the runs are structurally consistent. The same number of executions, no errors, so the comparison is valid. The key metric is total response time. In this case, the new run is significantly faster. Below that, we see distribution, how performance changed across queries. Most queries are within a narrow range, with improvement concentrated in the slower group. The slowest queries improve the most, which is where the performance gain matters the most. In this example, the variation was intentional. The database was restarted before the first run. In practice, you would establish a stable baseline before comparing the results. This answers a simple question: what changed between runs? Instead of analyzing each query individually, we can quickly understand the overall behavior. Your application is not the system. It depends on every component across the entire information ecosystem. We have shown how easy it is to define a test and execute it repeatedly to detect changes in queries, tables, the DBMS, its optimizer, libraries, and network infrastructure. By introducing parameters, these tests simulate real usage, with different users analyzing different customers, products, or geographies. This becomes a foundation for running test suites over time to detect system-wide changes, or to evaluate intentional changes like a new DBMS release, vendor, or infrastructure shift. Next, we'll build on this baseline to model realistic workloads where the system behavior becomes more meaningful.